Hello everyone and welcome to another video where today I will be talking about a follow-up experiment I did last weekend about the whole discussion with Kryptonite physics about how far you should be able to see the color of light, in my specific case LED lights. So just as a reminder, please, I will hopefully remember to link the first video of this discussion in the description. Please do go and watch it because it will be rather confusing if you don't, or maybe the first two videos even. Alright, so just as a reminder, what happened last time is that I calculated the expectations or the predictions made from Chris's way of thinking about color and how much you can see or when you can't see it anymore. And he's adamant that the threshold for human vision is I call it Chris's claim here in lux, and from that I calculated the distance from which you should be able to see it, and I went out to 85 meters and I could still see the red one. So clearly his prediction of 1.6 meter is completely wrong and ridiculous. As a matter of fact, in the comment section he first of all thanked me for doing an experiment, which I'm very happy about, but he then said that this looks like a much brighter LED to him than what I've listed here. He has provided no evidence for this assessment, and even with a much brighter LED, even with the numbers he claimed that my LED has, it wouldn't work. So good job doing the research there. However, my estimate was 1.5 kilometers. Without any kind of atmospheric extinction. And so I wanted to test this a little further because I only went to 85 meters. So let's test it a little further. Let's test. So how did I do these tests? Well, I used the same LEDs as before, but I included a blue LED this time. They all range from 0.1 candela to 0.4 candela. And I did the first test over about 200 meters and even a second one that went 550 meters. Not only did I do that, I also did a blind test where I asked the second person to help me, my flatmate. And so she would choose which color she shines at me, and she would write it down, and I would write down what I saw, and then we would compare it later to see how many I got correct. All right, so and then we exchanged one time for the 200 meter to see if there is a big difference between my eyes and her eyes, but you will see that in the video I took with my phone. Okay, and then the lists will be compared. So the first test was over 200 meters, so let's see how it turned out. Hello everyone and welcome to this, again, very special video where it is a repeat, or rather an expansion of the experiment that I did roughly 2 months ago with the extremely highly sophisticated circuitry, this time including a blue LED that I will conduct some tests with. But I'm not alone, my good friend and roommate is also here to help me do a blind test. Yes, that is correct. We have 4 different colors of LED and we will be standing approximately somewhere between 400 and 600 meters apart from each other. And she will then put on random LEDs, we agreed to about 15, and I will record the order in which she presented them to me, read it back to her, and so we can see if you can actually see color over much more than what Chris UK claims to do. Okay everyone, I'm just walking away here from my assistant, who only I will show the feet. Okay, so I'll walk over there now, a couple of 100 meters, and you can just stick with me. It is already very dark, as you can see, and there are clouds coming and the wind is picking up, so I believe we are expecting some rain, which would actually do us some good. Now I'm doing this experiment. I will certainly link the first part of the video or the first part of this series of these videos, because I think that they will be instrumental in understanding what I'm actually fucking doing here. But the gist is this. A flat earther by the name of Chris UK, or he was formerly known as Chris UK, now he's known as Kryptonite physics, has predicted that you cannot see the color of stars if they were as far away as they are away. And I think this is complete bollocks. I've calculated so, and my prediction goes out to being able to see an LED of a certain brightness. Again, all of this is explained in the first video, or in the first part, at 1.5 kilometers. So now I'm walking for about 500 meters to see if at least my ballpark numbers are correct. Now, I don't actually know the distance down here, but I will be walking until this forest here, which you don't see. You can see it now a little bit, begins, and then I will judge it afterwards from Google Maps, and if it's not sufficient, I may do a reshoot of the whole thing. Alright, so there is the forest now. This is not where I live. Usually I'm spending part of my Easter holidays with my parents. This is what I'm doing here. It seems rather creepy, but I assure you it is completely fine. I've been playing here loads as a kid. Okay, so now on a little bit of there's a field here, but I'm on the side of the field, and I will now be calling my assistant, who is over there, which you can't see. But yeah, and we'll start, I hope. Alright, so this is how this looks in practice. I won't hopefully be able to see anything. I hope the wind isn't too loud. But my friend is over there, and she's switching the LEDs. So far I've been able to see red, yellow, then something I believe was a phone flashlight, then yellow and blue and yellow. Currently I cannot make... Oh, now there comes something. I believe this is green. You don't see anything on the phone. Wow. Alright everyone, so I'm now walking back. Unfortunately you couldn't be seeing any of the things on video, so I didn't record it. I'm now walking back. I got 15, which is the number we agreed to, and I was only unsure with the ones that I believe to be green, because my green diode is not only the weakest, but I think, but it is also the one with the poorest color, kind of. It's not strikingly green, it's a rather yellowy, washed out green. Alright, so here we have the results, and as you can see very immediately here, the sender and receiver colors agree in every single turn. I hope I didn't make any mistake while transcribing the table, but this seems fine. So all of those have been correct. Now what does that mean? Well, I got 15 out of 15 correct over 200 meters. By Kryptonite physics' own calculations, with a light source that is when you need 0.04 lux to see the yellow LED, over 200 meters, it would have to have an inherent brightness of 1600 candela, which is completely ridiculous. We're talking about flashlight levels of light here, and this was an LED. This is completely... It's a joke. His conclusions are evidently completely off. And I will go even one further, because now let's have a look at how it turned out when we changed the people around. Alright everyone, welcome back. This is now the second turn. This is a day later. We are in the evening yet again, and we're at the same position that we did the roughly 230, I believe it was, meters test yesterday, because my flatmate has had an idea, and I think it is very good. Now she has rather poor eyesight. She has, I think it was beyond 6 diopter, and so she wanted to see how many she can see doing the exact same test. Now I have the LEDs, and we will do the precise same test as yesterday. Now if we recall, from yesterday I saw every LED rather clearly, particularly red, blue and yellow, given that green is the weakest one that we have. Pretty clear, so I'm curious how they will contrast now. For you stargazers out there, it is rather interesting. The Pleiades are actually very visible tonight. We will be doing some observations later, because given that we are both astronomers, and I can see 6 of the 7 stars that you could see with your naked eye of the Pleiades today, and she cannot see a single one. So her eyesight, even with glasses, because they're not adjusted correctly, she told me. So her eyesight is significantly worse than mine is. I'm blessed with my eyes, I must say. But yeah, so we'll be curious about how this is going to turn out. Alright everyone, now we switch to sender and receiver, where this time I was sending out the signals and my flatmate was receiving them and writing them down. As you can see, even with her poor eyesight, she managed to identify all of them. However, she did note that she was significantly less sure with the green ones. That is because I say in the video the green one is the weakest LED that we have. I don't think that that is quite that is not the case. The red one is the weakest, but interestingly enough, it was the one that I could see the best in all of the tests. Regardless, I think the thing about the green one is that it's very washed out. It's a very yellowish green, so it's kind of hard to distinguish between yellow and green sometimes. And the green LED, I think from what we are doing here, suffers the most from extinction relative to its brightness. Right, the blue one, of course, will be scattered the most, but so far the blue has held up fine because I believe the blue one is a bit brighter than the green one. So this is that, and now we go for a second round, an additional round, over 550 meters from the back of a barn, of whom I know the owner, and across a bunch of fields, and then over there where I would be. Now, how do we think that turned out? All right, here we are now at the second location. I hope the wind here is okay. I drove here with my very old bicycle that I haven't used in like 2 years. Unfortunately, I can only film this much because I don't want to spoil exactly where my parents live. But according to Google Maps, this is now truly 500 meters. The location earlier was about 230, 250 meters, that general area. So yeah, we're now doing this with 500 meters. If you recall, the 200 meter round went okay. Went pretty good, I'd say. And yeah, I'm curious about how it's going to turn out this time. Alright, so the results here are a little bit more interesting because actually I failed to see the blue ones every time. Not only did I not detect the color of the blue ones, I failed to see them completely. And with the green ones, I will admit freely that I could only judge the color of the green by knowing that it's not yellow, because there was enough difference there, and it certainly wasn't blue, but I could not tell, and of course not red, but I would not be extremely confident in saying that it was actually green. I still count it here, but just to know, because I correctly identified it, which was the setup of my test, right? So I got 12 out of 15 correct. I missed all of the blue ones. Over 540 meters, again, according to the way Chris would calculate this here, needing 0.04 lux to see color. In this case, for the yellow LED to be seen over 450 meters would require it to have 11,500 candela. We're talking about the brightest end of LED flashlights here. So I had a single LED, just one LED, and that was it. So his conclusions are so utterly and ridiculously wrong, right? So a little bit on speculation. Why? Because if you recall, I predicted around a kilometer, 1.5 kilometers, I believe, to be able to see them. And clearly at 500 meters, it starts breaking down. Why? Well, that's because the atmosphere scatters blue the best. We know that the blue light is scattered the most efficiently in the atmosphere. This is also why the sky is blue. And it's not a full black body spectrum, of course. So I really, the comparison between the LED and the star is only correct as long as you stay without extinction, because the line spectrum of a blue LED, here drawn in blue, and the black body spectrum of a star is clearly different. So and towards this end here, the atmosphere scatters very efficiently. So you would lose some of the light here, but of course the star would still emit in that area over here as well, which the LED doesn't. So it's in but in terms of color vision, this is because of atmospheric effects that I did not take into account in my calculations, mostly because in this specific case it would have been a little bit too difficult. Not to mention that the observing conditions weren't ideal. It had rained a small bit, and thus there was a lot of moisture in the air, which I suppose is not ideal. And it wasn't with the 500 meter test. There was a little bit of light in the background, but that is just the nature of where we drove. We drove for about 5 minutes to a place where I know people, so that I could be there on their property without breaking any laws. And of course there was background lights, but such is the nature. Nothing is perfect in human space, right? So but the important part here is that I was able to see the yellow LED, for example, or 450 meters and clearly identified as yellow. The red LED was even better because it is the least affected from atmospheric scattering. And Chris, in case you're seeing this, I really want you to ask yourself how I would be able to do that if I use the LED that I said I used. I would encourage you to repeat this test in similar conditions and see that you can see, for example, the red LED to 500 meters. This, according to your model of how you think this works, makes absolutely zero sense. And I would like to emphasize here, you're wrong. I'm sorry. At least you tried, but you're wrong. All right. And with that, I believe I can leave it there. Thank you so much for watching my videos. If you enjoyed this video, maybe consider leaving a like. If you enjoyed a lot, maybe considering subscribing. And I will see you in the next video and or in the next stream. Until then, have a good time. Goodbye!